You are thirsty in a way that is becoming a problem. Not the mild background thirst of a modern person who has been sitting at a desk for 3 hours and just noticed their water bottle is empty. The kind of thirst that has been building for a day and a half, that your body is now communicating through every channel available to it. The specific dryness in your throat that makes swallowing uncomfortable, the headache that started this morning and has been getting worse, the way your thinking has taken on a quality of slight fuzziness that you do not completely trust. You need water. Urgently. This is not negotiable, and there is water. Right in front of you, approximately 40 meters down a slope. A pool of standing water at the base of a rocky outcrop, fed by what looks like a seep, or a small spring from the rock face above. It is visibly water. It is accessible. It has solved your immediate problem in every physical sense. But you are not moving toward it. You are looking at it, assessing it, running it through some internal evaluation process that is producing currently a result somewhere between caution and outright rejection. There is something about it, and you are not even entirely sure what that something is yet, that is making your body say wait before your conscious mind has fully articulated why. This moment, the pause before the water, is the subject of today's video. Because the ability to evaluate water quality without any laboratory equipment, without any chemical testing kits, without anything beyond accumulated knowledge and trained perception, is one of the most sophisticated and most survival-critical skills that ancient humans possessed. And the specific mechanisms through which ancient humans knew which water was safe and which water would kill them are both more complex and more interesting than most people have ever thought to consider. Let's start with what contaminated water actually does, because understanding the threat is essential to understanding how ancient humans learned to assess and avoid it. Waterborne pathogens, the bacteria, viruses, protozoa, and other microorganisms that contaminate water sources and cause human illness, are the leading cause of death globally in populations without access to water treatment infrastructure. Cholera, typhoid, dysentery, giardia, cryptosporidium, hepatitis A. The list of serious and potentially fatal waterborne diseases is long, and all of them were present in the ancient world in forms that the ancient human immune system had been dealing with across the full span of our species' existence. The specific disease burden that waterborne illness imposed on ancient populations was significant. Children in ancient communities, with less developed immune systems, less accumulated immunity from previous exposure, and higher susceptibility to the dehydration that severe diarrheal illness produces, were particularly vulnerable. Archaeological and paleopathological evidence from ancient human remains consistently shows evidence of chronic parasitic infection and the specific bone changes associated with severe childhood illness, including gastrointestinal infections. This means that in the ancient world, water quality was a genuine, serious, frequently lethal concern. Communities that made consistently poor water choices suffered significantly higher mortality rates than communities that reliably found and used safe water sources. The ability to assess water quality was not a trivial skill. It was survival infrastructure, as important in its domain as fire management or food knowledge. And ancient humans developed it. Through the specific mechanisms of empirical observation, accumulated cultural knowledge, biological sensory systems calibrated to relevant water quality signals, and the specific ecological intelligence that developed from sustained observation of the relationship between water sources and the health outcomes of people and animals that used them. Let's talk about the sensory systems that humans have specifically for water quality assessment, because evolution did not leave ancient humans without biological tools for this problem. The human sense of smell is significantly more capable than most people appreciate in the specific domain of detecting water contamination. The olfactory bulb, the brain structure that processes smell, is connected directly to the limbic system, the set of brain structures involved in emotional and motivational processing. This direct connection, bypassing the cortical processing that most sensory information undergoes, is the reason that smells produce immediate emotional responses and are uniquely effective at triggering avoidance or approach behaviors. The specific chemicals that produce the characteristic odors of water contamination, hydrogen sulfide from anaerobic bacterial activity, various organic compounds from algal blooms, ammonia from nitrogen-rich animal waste, the specific chemical signatures of different categories of microbial contamination, are detectable by the human olfactory system at concentrations that are relevant to actual contamination risk. The threshold detection concentrations for many of the chemical markers of water contamination are in the same range as the concentrations at which those compounds begin to indicate genuine contamination risk. This is not coincidental. It reflects millions of years of selection on the primate olfactory system in an environment where contaminated water was a genuine mortality risk. The humans whose olfactory systems could detect the relevant contamination signals at relevant concentrations survived and reproduced at higher rates than those whose olfactory detection thresholds were too high to be useful. Over generations, the human sense of smell was tuned, specifically and functionally, to the specific chemical markers of water contamination. The specific disgust response that bad-smelling water triggers, the automatic, immediate, physically strong aversion that most people experience when they encounter the smell of contaminated water, is the motivational complement to the olfactory detection capability. It is the behavioral expression of the neural connection between olfactory detection and limbic aversion. The smell is detected. The limbic system produces a strong negative emotional response, and the behavioral result is avoidance. This is exactly the biological circuit you want when the thing you are detecting is genuinely dangerous. Let's talk about visual water quality assessment, because the ancient human evaluation of water safety extended well beyond smell into the detailed visual analysis that the human visual system is specifically designed to perform on complex natural stimuli. Color is one of the most immediate and most informative visual water quality signals. Clear, colorless water is not a guarantee of safety, but turbid, colored, or visually distinctive water provides specific information about the conditions producing those visual characteristics. Green or blue-green discoloration of standing water indicates algal bloom, potentially including toxic cyanobacteria that produce compounds harmful to both humans and animals. Red or reddish-brown discoloration can indicate iron contamination, or the specific biological blooms associated with it. Milky or white turbidity can indicate mineral precipitation or suspended particles. Black or darkly discolored water indicates high organic matter content and the specific microbial activity associated with decomposition. These color signals are not definitive diagnostic indicators in the way that laboratory water testing is, but they are genuine signals. They encode real information about the conditions of the water source that ancient humans could read and interpret within a framework of accumulated experience that told them what those signals predicted about health outcomes. Ancient humans who had observed, over a lifetime, and across the transmitted knowledge of multiple generations, that people who drank from green-tinged pools got sick, while people who drank from clear springs did not. Those ancient humans were in possession of a functional, empirically validated, transmission-tested body of water quality knowledge. The specific observations and the specific outcomes had been connected across enough iterations, in enough different people, over enough time, that the pattern had been confirmed, encoded in cultural knowledge, and transmitted as reliable guidance. The clarity of water tells you things beyond color. Water that is turbid with suspended particles, even particles that produce no color change, is water that has been recently disturbed or that flows through soil conditions producing high sedimentation. Turbid water carries higher pathogen loads than clear water because the surfaces of suspended particles provide attachment sites for bacteria. Ancient humans who had learned empirically that turbid water from certain source types more often produced illness than clear water from similar source types had derived a functional water quality heuristic that modern water quality science confirms. Let's talk about the most important single water quality signal that ancient humans used: the behavior of animals. Animals are the most powerful and most reliable water quality indicator available in a natural landscape, and ancient humans, whose ecological intelligence included extraordinarily detailed knowledge of local animal behavior, were reading this indicator continuously and skillfully. Here is the logic. Animals in a landscape have been using the same water sources for generations. They have the same biological vulnerabilities to waterborne pathogens that humans have. In some cases greater, in some cases different, but equivalent in severity. Water sources that are reliably contaminated produce consistent illness and death in the animals that use them, which produces consistent avoidance of those sources by the healthy animals of the local population. Water sources that are reliably safe are reliably used by the healthy animals of the local population. An ancient human who observed that the deer and the horses and the elephants and the zebras all gathered at a specific water source, that they drank freely and showed no subsequent signs of illness, had very strong evidence that this water source was safe for consumption. An ancient human who observed that a specific water source showed no animal use, no tracks, no evidence of recent animal presence despite the animals of the area clearly needing water, had very strong evidence that this source was not safe. The specific distribution of animal tracks, the frequency of animal use of different water sources, the health and behavior of the animals using those sources, all of this was environmental information that ancient humans read continuously as part of the normal ecological intelligence activity of navigating their territory. This is not intuitive guesswork. It is a rational inference from a very well-developed monitoring system. The animals of the landscape had been doing the empirical testing of local water sources continuously, with their own health as the outcome measure, for far longer than any human community had been present. Their collective behavioral evidence about which sources were safe and which were not was more extensive, more locally calibrated, and more continuously updated than any human community's direct experience could have been. Ancient humans who understood this were using animals as a distributed water quality testing network, which they were. Let's talk about the specific ecology of safe versus unsafe water sources, because ancient humans developed detailed knowledge of the landscape features associated with water quality that was functionally equivalent to modern hydrogeological knowledge. Moving water is generally safer than standing water. This is a well-established principle of water quality, and it reflects real biology. The flow of moving water reduces the concentration of pathogens through dilution, provides insufficient residence time for many pathogen life cycles to complete, and creates conditions of aeration and temperature variation that are unfavorable for many pathogenic organisms. Ancient humans who preferentially sought moving water over standing water were applying a rule that water quality science confirms. The source of water matters enormously. Groundwater emerging from rock or deep soil as a spring carries the specific filtration benefits of having passed through geological media that remove particulate matter and many biological contaminants. Rainwater collected before it contacts the ground is free of the soil-derived microbial contamination that ground contact water carries. Surface water from areas with high animal density carries significantly higher pathogen loads than surface water from areas of low animal density. Ancient humans with detailed knowledge of their territories had a spatial map of water quality that was encoded in the accumulated knowledge of their community across generations. They knew which springs were reliable and clean, which streams became unsafe at specific times of year when upstream conditions changed, which pools collected after rain and were safe to drink from when fresh but became dangerous after several days of standing, which areas of their territory had surface water that was reliably contaminated by the concentration of animals at specific times of year. This spatial water quality map was not written anywhere. It existed in the minds of the community's most experienced members and was transmitted through the specific oral traditions that preserved survival-critical knowledge across generations. The elder who said, "Do not drink from the eastern pool in the dry season," was transmitting a water quality assessment that had been validated through generations of empirical observation, even if the specific mechanism, what made the eastern pool dangerous in the dry season, was understood in ecological rather than microbiological terms. Let's talk about the specific practices that ancient humans used to make questionable water safer, because assessment and avoidance were not the only tools in the ancient water safety toolkit. Fire and boiling represent the most effective water treatment technology available without modern infrastructure, and there is good evidence that ancient humans understood and used this technology in the contexts where it was accessible and necessary. Boiling water produces immediate and effective destruction of bacterial and protozoan pathogens, reduces viral load significantly, and eliminates the specific threat categories that represent the most immediate waterborne illness risks. The specific knowledge that boiling water made it safer, that people who drank water that had been heated over fire were less likely to become ill than people who drank the same water unheated, is the kind of empirical observation that ancient communities with fire technology had the ability to make and the motivation to make, given the mortality stakes of waterborne illness. Whether ancient humans understood why boiling worked is a separate question from whether they observed that it worked. The documentary and ethnographic record of traditional communities worldwide consistently shows the practice of preferentially boiling water in contexts of uncertain water quality. The antiquity of this practice is difficult to establish archaeologically. The behavioral pattern leaves no specific physical trace distinct from other fire uses. But the combination of fire technology availability and water quality necessity makes it a plausible ancient practice with significant supporting logic. Plant-based water treatment is a separate and genuinely fascinating dimension of ancient water safety practice. Multiple plant species produce compounds with antimicrobial properties that, when added to water, reduce pathogen loads to levels that reduce illness risk. Certain plant barks, seeds, and roots have been used as water treatment agents in traditional communities across Africa, Asia, and the Americas. Moringa oleifera seeds, which contain specific proteins that cause bacterial cells to clump and precipitate out of suspension, have been used as a water clarification agent in African traditional communities with documented effectiveness that modern water treatment researchers have confirmed in laboratory settings. Several other plant species with similar antimicrobial or clarification properties appear in the traditional water treatment practices of communities worldwide. Ancient humans with detailed botanical knowledge, and we have established in other discussions that ancient botanical knowledge was deep, specific, and empirically grounded, had access to these plant resources and the observational framework needed to identify their water treatment properties. The connection between adding specific plant materials to water and improved health outcomes among people drinking that water was the kind of cause-effect observation that ancient empirical knowledge systems were specifically designed to make and retain. Let's talk about the role of taste in ancient water quality assessment, because this is more interesting and more functional than it might initially seem. The human taste system includes specific receptors for several of the chemical markers of water contamination. Sulfur compounds, which indicate anaerobic bacterial activity, are detectable as bitter or sulfurous tastes at low concentrations. High mineral content, which can indicate specific geological contamination sources, produces distinctively mineral or metallic tastes. High organic load produces earthy, musty, or putrid tastes, depending on the specific biological community producing it. The bitter taste response, one of the most immediately aversive taste responses in humans, shared across all human cultures in its basic properties, is specifically calibrated to compounds that are often toxic. The bitterness of water from specific contaminated sources is frequently produced by the specific chemical compounds, algal toxins, mineral contamination, metabolic byproducts of pathogenic microorganisms that make the water dangerous. The bitter taste response is the body's last line of sensory defense. If something got past your nose and your eyes, maybe your tongue will catch it. Ancient humans who had learned to trust the taste aversion response, who had noticed, or whose community knowledge encoded, that water that tasted wrong more often produced illness than water that tasted fine, were using a genuine functional diagnostic tool. Not infallible. Some dangerous contaminants are tasteless, some unpleasant tastes are from harmless compounds, but better than chance, and better than no assessment at all. The specific training of the taste system, the learning of which specific taste qualities were associated with which specific outcomes, was part of the accumulated experiential knowledge that ancient communities transmitted across generations. The child who was taught that water that tastes like this is not safe was receiving empirically validated guidance encoded in a memorable, directly actionable form. Let me bring you back to the pool at the beginning. You are still looking at it. Your thirst has not changed. The water is still there, 40 meters away. But in the pause since you first saw it, your evaluation has been running. The smell is wrong. Not dramatically wrong. Not the obvious, overwhelming sulfur stench of heavily contaminated water. Subtly wrong. A quality in the air near the pool that your olfactory system is registering as not right in a way that is activating a mild but persistent aversion response. You did not consciously decide to think about smell. Your nose just told you something. The color is slightly off. A tinge that is barely perceptible in the afternoon light, but that, looking at it carefully, is not the colorless clarity of safe water. Something slightly greenish at the shallow margins. There are no tracks at the edge. This is the thing that is bothering you most. You can see the mud at the water's edge clearly, and it is smooth. No hoof prints, no pad marks, no bird tracks in the wet margins. For a water source in this landscape, in this season, the absence of animal use is itself information. The animals know something about this water that their absence is telling you. There is a spring 2 kilometers east, uphill, where the rock changes from the dark sedimentary to the lighter granite. You have been there before. It is 2 more kilometers of thirst, but the water there is clear and cold, and the ground around it is tracked by every animal in the area and has been safe every time you have used it. You turn east. That decision, made without a laboratory, without a pH strip, without any technology beyond accumulated knowledge and trained perception, is the specific ancient water quality assessment system in action. And it works. Not perfectly, not every time, not without the occasional catastrophic error that taught the next generation what not to do, but reliably enough, across enough generations of accumulated and transmitted knowledge, that ancient humans managed to keep themselves adequately hydrated across the full range of environments they inhabited. They looked at water the way they looked at everything in their environment, as a complex system carrying specific signals, readable with the right knowledge, accessible with the right perceptual skills. They built those skills across generations of careful observation and costly experience. And they encoded what they learned in cultural knowledge that persisted and accumulated and was available to every subsequent generation of their community. They knew which water was safe. Not perfectly, not always, but reliably, practically, survival adequately, they knew.